Hello friends, myself R.I.D. Mahajan, Assistant Professor, MIT, Aurangabad, presenting my video on the topic curve tracing, second part. In the previous part, I have discussed first 2 points, whether curve passes through origin or not, and symmetry. The remaining 3 points I will discuss in this video. Point number third, point of intersection. Uh, there are 2 points. If curve is symmetrical to x-axis, put y equals to 0 to find point of intersection with x-axis. And second, if it is symmetrical to y-axis, put x is equals to 0 to find point of intersection with y-axis. For example, we take y square is equals to ax cube. Curve is symmetrical about y-axis, and therefore to find the point of intersection with x-axis, put y equals to 0. Therefore we get y equals to 0 here. Dividing by a, we get x cube equals to 0. It implies x equals to 0, and therefore the point of intersection is 0, 0 with x-axis. Second example, y square is equals to x cube a minus x. Here power of y is even, means curve is symmetrical to x-axis, and as curve is symmetrical to x-axis, put y equals to 0. Therefore y equals to 0, we get x cube a minus x. Product of two term equals to 0. It implies first term equals to 0, and the second term a minus x equals to 0. It gives you x equals to 0, and this gives you x is equals to a, and therefore the points are x0 when y0, x is a when y is 0. Therefore we get 2 point of intersection. One is 0, 0, second is h0. And whenever we are getting more than one point of intersection other than origin, then we have to shift the origin. Shifting of the origin. This point we have to perform. Okay. What is the meaning of shifting of origin? The original coordinates of origin, suppose xy, from this we have to shift it to point a0. In the process of shifting, change in x coordinate is x plus a, and change in y coordinate is y plus 0. These are the point of intersection. Okay. And curve is passing through this point, means it will lie on that curve, and as it will lie on the curve, it will satisfy that equation. Therefore, if we replace y by this new y, therefore it is y cube. X cube means x plus a cube and a minus x. X is here, x plus a. If we simplify it, if we expand it, we get expansion as a cube means x cube, 3x square a, 3x a square plus b cube means a cube, a cube 3a square b plus 3ab square plus b cube, expansion of this. And if you simplify this, that is a minus a get cancelled, we get minus x. And then at this new point of intersection, we have to find out the origin. Therefore, we follow the same procedure. Find the lowest degree term or terms. Therefore, degree of each and every term I will determine. Degree of this term is 3. Degree of this term is 4. Degree of this term is 3. Degree of this term is 2. And degree of the last term is 1. Therefore, the lowest degree term is minus a cube x equals to 0. What it implies? It implies x equals to 0. X equals to 0 means y-axis is the tangent at the new origin. Okay, like this we have to perform. Therefore, once again I will repeat. Whenever we are getting any point of intersection other than origin, then we have to complete this step of shifting of the origin, and the purpose is to find out the tangent at that point of intersection. And tangent helps to decide the shape of the curve. As here x-axis, x equals to 0 means y-axis is the tangent at that point of intersection. Suppose the point of intersection is A0 somewhere here approximately, and at this point of intersection y-axis, new y-axis is suppose the tangent, and whenever we are getting such type of tangent, we have to plot the curve, shape of the curve slightly parabolic. Okay, that is the use of finding the tangent at the new origin to decide the shape of the curve. Okay, always we have to draw a slightly parabolic part whenever we are getting any line as a tangent at some particular point. Therefore, this is about the third point of intersection. Point number 4. This is one type of a line which is tangent to the curve at point of infinity. That type of tangent or that line is called an asymptote. Therefore, first of all, we define this term asymptote. An asymptote is line which is tangent to the curve, which is tangent to the curve at point of infinity. And procedure to find if the curve is symmetrical to x-axis, if the curve is symmetrical to x-axis, we will get asymptote parallel to y-axis and if the curve is symmetrical about y-axis, then we get asymptote parallel to x-axis. Means if curve is symmetrical to x, we get asymptote parallel to y-axis and vice versa. Means if it is symmetrical to y-axis, we will get asymptote parallel to x-axis. And to obtain asymptote parallel to x-axis, parallel to x-axis or y-axis, parallel to x-axis or parallel to y-axis, equate the coefficient of highest degree term or terms in x or in y to 0. For example, we consider the equation as y square a minus x is equals to, suppose, x cube. Cartesian equation, explicit type, y we can express as function of x. We go for all the points whatever I have discussed so far. Here the power of y is even, therefore curve is symmetrical about x-axis. Then point number 2, whether it passes through origin or not. Put y equals to 0, put x equals to 0, we get 0 equals to 0, means curve passes through origin. And as it passes through origin, we find the tangent at the origin, equating the lowest degree term or terms to 0. Here the degree of the first term is 2, degree of second term is 3, degree of third term is 3. Therefore, the lowest degree term is ay square equated to 0. Dividing by a, we get y square equals to 0. It implies y equals to 0 and y equals to 0, x-axis as a common tangent. And as we get common tangent, at the origin we get a cusp. Then third point of intersection. Put y equals to 0 in this equation. Therefore, if we put y equals to 0, we get 0 equals to x cube. It implies x equals to 0. That gives the point of intersection as x0 when y0. Only one point of intersection, that is the origin. Therefore, no need to perform shifting of origin. Therefore, first 3 points I have completed. Next point, asymptote. As the curve is symmetrical to x-axis, we get asymptote parallel to y-axis. And to obtain the asymptote parallel to y-axis, find the highest degree term in y. Therefore, only one term of y, that is y square. Its coefficient is a minus x. Equate that coefficient to 0. This gives you x equals to a. Therefore, this line x equals to a is the asymptote parallel to y-axis. Okay, like this we can. Therefore, this is the important procedure to find the asymptote, either parallel to x-axis or parallel to y-axis. Okay, therefore, if I try to show this, curve is symmetrical to x-axis. It is passing through origin, and at origin we get a cusp. Pointed shape. No any other point of intersection other than origin. Then point number 4, asymptote. X is equals to a line parallel to y-axis. Therefore, approximately if we show this line as x equals to a, this line becomes a tangent to this curve, and this is the tangent at point of infinity. Therefore, it is not possible for us to show that point of infinity. Therefore, indirectly we show this line as a tangent by drawing a part of the curve parallel to this line. Therefore, I will draw a part of the curve which is parallel to this line, symmetrical about x-axis. And then if we join this, this line is called as the asymptote. Okay. In detail, I will explain when I will go for the actual example. Therefore, at this stage only remember the procedure how we can determine the asymptote. And the last point, where curve exists or where curve does not exist. if curve is symmetrical to x-axis, if the curve is symmetrical to x-axis, solve the equation for y. And if the curve is symmetrical about y-axis, solve the equation for x. And then after solving it either for y or x, if we solve it for y, determine the values of x for which curve does not exist. And if we have symmetrical about y-axis, we have to solve it for x. Find the values of y for which curve does not exist. Therefore, if we complete all these 5 points, and after completion try to show it in figure to obtain the tracing of that curve. I will explain by solving some simple examples how we can get the figure of Cartesian curve. And my next part, third part of the video for this curve tracing, Cartesian curve tracing. Therefore, if you are watching my videos, please like and share it, as well as subscribe to my channel. Thank you. Thank you.